Hi everyone. In this section, we'll do the lab focused on Delta Lake tables in Microsoft Fabric. Delta Lake is a game changer for data lakes. Traditional data lake stores CSVs, JSON, Parquet, but they lack critical database features like there is no transaction, no schema enforcement, and no reliable updates. Delta Lake solves these problems by adding a transaction log to your data files. Here how it works. Delta tables are stored in Parquet files, but with a special underscore delta underscore log folder. And these logs tracks every changes to the table, like inserts, updates, deletes, schema modification, like creating a reliable and auditable history. So this enables ACID transactions, meaning your data operations are atomic, consistent, isolated, and durable. In Fabric, Delta Lake is the default format for Lakehouse tables, and for good reason. In this lab, we will explore the difference between managed tables and external tables. So, managed tables store both data and metadata in your Lakehouse. Fabric controls everything for optimal performance. On the other hand, external tables separate the two. Metadata lives in Fabric, but data files can be anywhere, another lakehouse, Azure storage, or even on-premises systems. This gives you flexibility for data sharing and federations. We'll learn to create delta tables using both Python data frames and SQL DDL statements. DDL is data definition language. There is an option like the save as table method in PySpark, which is the default language for data fabric, uh, is your go-to for managed tables. And while SQL create table with a location clause defines external tables. Now, one of the Lake's most powerful features is time travel. Because every changes is logged, you can query previous version of your data. Made a mistake, roll back. Need to audit changes, compare version, all possible. With a simple version edge of queries. We'll also work with streaming data. Delta table can serve as both sources and sink for Spark structure streaming. In this lab, we will simulate IoT device data streaming into a Delta table, demonstrated how Delta Lake handles continuous data ingestion and while maintaining the query consistency. The SQL query interface lets us analyze Delta tables using standard SQL. Again, we can create views and temporary tables to simplify complex queries. By the end of this lab, you will understand why Delta Lake is the foundation of modern lakehouse, combining the scalability of data lakes with the reliability of data warehouse. So let's explore Delta tables and unlock the full potential of lakehouse. So now we are going to do lab use Delta tables in Apache Spark. So tables in Microsoft Fabric Lakehouse are based on open source Delta Lake format. Delta Lake adds support for relational semantic for both batch and streaming data. In this exercise, we will create delta tables and explore the data using SQL queries. Let's start plan. So very first thing, we are going to create a workspace. So create a new workspace. So 033 and make sure under advanced section that fabric capacity is enabled. Click on apply. So it creates an empty workspace. Now we are going to create a lake house. Give a name. Under that workspace, click on create. So you can see that on the Lakehouse, there are two options. Some browse, we can browse tables and files. Right now they are empty. So let's get the data we have got. So under files, we are going to create a new subfolder called products. So this subfolder, we're going to create a folder called products. And we have saved a file, this one, product CSV. So we are going to upload that file here. So if you see here, files has been uploaded here. Now we'll explore the data in data frame. For that we are going to create a notebook. So under that workspace, click on new item, create a notebook, give a name, click create. So when you create a notebook, it's ultimately open that notebook page. So here we can, this is a code block, we can make that like a markdown cell and edit that one. And I put cursor outside, so it will get as a markdown block. Now in the Explorer pane here, the option on the data items, there's option that add data items. Click on there, and existing data source, we're going to add the data lake house that we created, and click on connect. So when that is done, let's add a new code block and going to read the data in a data frame using a defined schema. So that way it's coming definite. Unlike in the schema definition, it's based on these 4 columns. So let's execute that one. So by see here and here, you know that's this code block is running. So you can see that the 4 columns that we selected, so it's there. So it's defined this schema based on that one. It's then after that it's created data frame. So now we are going to create delta tables. You can save the data frame as a delta tables by using the save as table method. Delta Lake support the creation both managed and external tables. So managed tables is the data tables benefit from the higher performance, and external tables is allowed to store data externally, like with the metadata managed by Fabric. So create a managed tables. So under the tables is that the data files under the tables folder, and then you can see here the option add data items. For me now just create a do that one by create a code icon. I'm already in here. So now here is that we are use save as table. So it's coming as a managed. So let me execute that one. So you see that session is ready, that means it has been executed. Now refresh this table portion, and we can see that manage products table has been created, and the triangle icon you see, that indicates the delta table. So these files for managed tables are stored in the tables folder in the Lakehouse. So if we expand that one, let's see, you can see all those columns for these tables. So managed product has been created with stores that, let me see, we can see an info, copy path, load data, rename, no, here, no, okay. Now we are going to create an external table. So for that, let's add another code block. Here's the code. Now there is a ABS path, so we can get that path by going through that files folder and see that the copy path, paste here. So now execute that one. So it's executing. You can see also time from here. So that has been completed and session ready. So now if I go to under files, let me refresh, and we can see that an external uh, products has been, like, that folder has been created here, and there is it, and like, let me see the files. Files option is not there, but here you can see those stats and commits underneath that one. And if you go here, refresh this page, and here you can see also it created here under table external products. It's kind of metadata reference here. So now what we'll do, we'll compare this managed and external tables. So for that, let's go in a new cell. So this is managed one. We are executing. So here you can see column name, data type, this one. And if we go, that was for managed product, and let's go for external product, then I'll show you what the difference. Discrete command normally give you the table columns name and the data type. So here, if you see the location, you can get the location from here. So location value in the two options. See the difference here. Location value maximize this one. Oh, it's big path. So this is managed products. How I can close location. Let me zoom out so you can compare that one. So location value in the data type column, to see the full path, you will see that it's actually pointing to storage location. This is external products, and this is system related. Let's see, and it's going to tables level, tables manage product. Now let's go to a new cell and going to drop those to see what happened here. So here you can see this is external products, or this is under files. You can see the external products. So now if we drop those, so those are dropped. Now if I refresh this one, is still there. Refresh the page. Now you don't see that external products tables under table, but if we do refresh under files one, so still we can see that has not been deleted. So external products under files is still there, and if we select, we can see that on both parquet file and delta log is there. So what we see here, that metadata for the external table was deleted, but not the data file which is sitting there, that has not been deleted. Now let's use SQL to create a delta table. So we are going to create a data table under external products here. So if we refresh, and we can see that product table is listed, and we can expand to get all the details down below. Let me refresh here. You can see all these columns here, and add another cell. We can also execute select command, because we are executing SQL, Spark SQL. So we are just executing different SQLs here. So you can also see that data from the table, products table. Now we are going to do table level versioning. Transaction history for the tables is stored in JSON files into that the data folder log, that directory, and we can actually query from there. Like for the particular table, like we would like to see here, which actually that 10% reduction in the price for mountain bike. So we are going to update those products into that category. And here we're just describing that products table, that history wise. And from history wise, you can see that timestamp, and you can see the version here and what has been done. So you can get the table versioning from here. Let's add another code. Uh, so here what I'm doing that get the current data and get the version 0 data. So here you see that two sets, one is down, one is up. So one containing the data after the price reduction and other showing the original version. So you can also get the value or compare the value. So the current data, and you can see this bottom one is that original version data. Now analyze delta table data with SQL queries. So like SQL statement we're going to execute. So let's execute some SQL here. So you are going to create a view this time, so that it's create a view based on this. If you are good with SQL, you know all these things. So then after creating that view, and then we are query data from that view. So view has been created, and finally we are getting this data from the view. Now we are going to execute a SQL to return the top 10 categories, uh, top 10 categories by number of products. And when that value is coming, we can see that built-in chart where we can click and we can display the charts here. And we can also like run this query using PySpark. Let's do more SQL. So here we are going to get category maximum price, minimum price, average price from that products view, and then order by based on average price, and it is limiting 6. I got that 6. Now use delta tables for streaming data. So like data, delta lake supports streaming data, and it can be a sink or a source for data streams created using the Spark structure streaming API. So let's do some SQL on that. So you're going to create a folder, then create a stream that reads data from that folder using a JSON schema, then write some event data to the folder. So if you execute that one, we'd like to see a message that source stream created. So you can see that source stream created is displayed. So it has created a streaming data source based on a folder to which some data has been saved. Now we are going to execute this SQL. So it ultimately uh, writes the streaming device data in delta format to a folder named IoT device data. So let's execute that one. You see that under tables IoT device data. Now when that has been created, we can just query the data table. So if you see here, so ultimately this table, IoC device data table, contains the device data from the streaming source that we created. Now we are going to add more data into streams. Now we'll see if we query that table, we'll get this data also. So you can see those data is there. Now that is stream table, we can see that one. Now, because streams is running, so to stop that one, we can just run the below SQL. Oh, we have already executed. So this actually stop the stream. That's all for this lab. We have successfully completed. And now let's clean the workspace. It's always better to lab environment. Clean the workspace. Go to workspace, from workspace settings. Then under sometimes a bit slow, under general section, go at the bottom, remove this workspace. That's it for this lesson. See you in next lesson.